Let us consider the right triangle ABC with two given sides and find the unknown side, the side AC or the side B. So usually when we have an angle B, we denote the angle with the uppercase letter B. The opposite side we denote with a lowercase b. If it is a right triangle, we can apply Pythagorean theorem. Pythagorean theorem always states that this hypotenuse squared, the side opposite to the angle C squared, equals to sum of squares of two legs, b squared plus a squared. So the side opposite to the right angle C is C, and this time it's equal to 8. The side opposite to the angle A is A. So two sides are given, C and A. We want to find B. We solve this equation for B. We subtract a squared from the left and from the right and get b squared equals c squared minus a squared. We can substitute c and a on this step. C squared is 8 squared minus a squared, 5 squared. 64 minus 25 equals 39. So to find b, we must take square root of this equation. So b squared equals 39 means b equals square root of 39. Here we don't need to write positive or negative, since the length cannot be negative. It's not sine or cosine, it's the length of the side is always positive, so that's why we take positive sign. Now let us find trigonometric functions of angle B. So in terms of a right triangle, we use opposite or adjacent or hypotenuse. So sine of B is opposite over hypotenuse. Opposite side is B, hypotenuse is C, square root of 39 over 8. Cosine of B, cosine B is adjacent over hypotenuse. Adjacent side is A, hypotenuse is C, 5/8. Tangent of B, tangent is opposite over adjacent, or B over A, square root of 39 over 5. And reciprocal function, reciprocal of sine is cosecant of B. So the reciprocal will be 8 over 13 square root of 39, square root of 39, and we want to rationalize denominator, so we multiply by square root of 39 numerator and denominator and get 8 square roots of 39 divided by 39. Reciprocal of cosine, secant B, reciprocal of 5/8 will be 8/5, and reciprocal of tangent is cotangent B. So tangent is square root of 39 over 5, then cotangent will be equal to 5 over square root of 39, and again we have a square root in denominator, we want to rationalize it. So we multiply by square root of 39 numerator and denominator and get 5 square root of 39 divided by 39. Let us write cosine of 20 degrees 15 minutes in terms of its cofunction. So above we had three pairs of functions, reciprocal functions: sine, cosecant, cosine, secant, tangent, cotangent. Co-functions are different, a little more different. Also, we have pairs of the same function but different pairs. So co-functions are sine of theta and cosine of theta, secant theta, cosecant theta, tangent theta, cotangent theta. You see, sine, cosine, secant, cosecant, tangent, cotangent. So these are pairs of co-functions, and we have an excellent property for them. Cosine of theta equals to its cofunction. The cofunction of cosine is sine of 90 degrees minus theta. We can write the same for all three pairs in both directions. So sine of theta equals cosine of 90 minus theta, and so on. So let us use this for cosine 20 degrees 15 minutes. It must be equal to sine 90 degrees minus 20 degrees 15 minutes. And let us simplify it a little bit. So we want to subtract 20 degrees 15 minutes from 90 degrees. 90 minus 20, 70 degrees minus 15 minutes. To subtract 15 minutes, we will take 1 degree from 70. So 70 is 69 plus 1. 69 plus degree plus 1 degree minus 15 minutes. 69 degrees. 1 degree is the same as 60 minutes minus 15 minutes. So it will be 69 degrees, and 60 minus 15 equals 45 minutes. Sometimes it is important to write it not in degrees and minutes, but in decimal degrees. So let us transform to decimal degrees. 69 plus 45 minutes in terms of degrees will be 45 multiplied by 1/60, since 1 minute is the same as 1 degree divided by 60. So 45 divided by 60 is 3/4 or 0.75. This is equal to 69 degrees 69.75 degrees. So either this or that is correct depending on the question. So this was the calculation of the degree. So the answer for the problem will be sine of 69 degrees 45 minutes.